Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem in the list is search in rotated sorted array second. And this might be the craziest problem that people find, that's really hard to approach, even though you understand the problem so well, but it's so hard to put down the code. and I think a lot of people who have tried to explain it on YouTube, they go through the same process, but I am going to do it I'm gonna do it so good. You'll be surprised how easy it actually is if you basically approach it in the right order, which was, we did this problem first. That was find minimum in rotated sorted array, right? And this was this simple code that we wrote, which is basically finding that minimum element in that rotated sorted array. There was an array which was sorted, but later it was rotated. You know what rotation means. And so this is the code that we use to basically find that minimum element, right? Basically having these two pointers and then finding where is this pivot element, basically where right after including that element everything is sorted, and before that everything is sorted. That's the pivot element I'm talking about, and that must be the minimum element, right? That is the minimum element. After that everything is sorted in the right half and everything sorted before that. We utilize the same logic to basically find that pivot element, that midpoint, basically that minimum element in this sorted rotated array, and we use this particular logic right here. This code is same as this code, okay? If you remember, if you haven't seen those two videos, please check it out. But this is what we basically used to find this pivot element, which is basically this R. Later we found out this R was the pivot element, which means everything before this was R was sorted, and everything including R after that it was sorted. So what we did in this problem is, by the way, search in rotated sorted array. This is the first part of the first problem, basically these are two different problems, right? So in this problem what we did is I want to go in this order, right? I want to go in this order because this particular problem, this second problem, is the exact same description, except just one little thing: there could be duplicate values. Previously there were no duplicate values. It was just every value is unique here, and once we find out that midpoint, we basically apply this binary search on both parts, although we didn't have to, but I just found this is easy to think of. If you found this pivot element, just apply binary search on first and binary search on second, and whatever returns the answer, just return it. We could have done it in this way, that since we have these ranges, we can check where does our value lie, this target value, where does this target value lie, and whichever range it lies in, by making two if else, and then return that answer. But this also worked. This was also accepted, and it's pretty efficient, right? So now what should change to handle those duplicate values? And I'm sure you have gone through the description, and you must have gone through this problem basically if you're following the order, but you must have gotten stuck somewhere, how to basically handle those duplicates. And that's what we will do. We will basically have the exact same code and just very two-line minor changes, and that will basically change the solution and make it run over here. But remember, this solution is also based on finding that minimum pivot element. So if you haven't done that, do that first, then do the first one, the search in rotated sorted array first problem, and then let's do this problem, which is basically search in rotated sorted array second. Okay, same problem, just some duplicate values. Let's switch the view, understand the problem. What is it asking us? We already understood, but let's just go over it again. So this time also we have this array given to us, which was sorted in the beginning. Let's say in the beginning it must have been like 0, 1, 2, 2, 2, 5, and 6. So this must have been the original array before it was basically rotated. So what does rotation means? We take one element at a time, and each rotation basically brings that element forward. In this case as well, what must have happened, it just did this much of rotation. It did 3 rotation and made the basically change this array that was basically originally like this to what is given to us like right now. Okay, now we have understood what does it mean to be rotated sorted array. So now this is rotated sorted array which has duplicate elements. Now we need to find this target 0, and if you remember, how we did in the first problem was basically having this particular little algorithm to basically find this minimum element, and once we found this minimum pivot element, okay, I'm gonna copy this. Once you find this minimum pivot element, then what you do is basically run this binary search function. That, of course, if we are doing the series binary search, then we have gone through that little piece of code, binary search, like so many number of times. So we just wrote it in helper function and just ran it on both the sides of this pivot element. So how about, what do we need to change when we basically, what goes wrong? Let's understand what goes wrong if basically we run this on our example. And I have just selected this nice example for us where actually we'll see the problem really clearly and see why we actually really needed to do that. So let's say we run this over here, and I'm gonna just like erase this first example. I've chosen like this custom example for us so that it will be easy for us to understand. Okay, this is our example. So what we were doing over here, if you remember, is that we have in order to find this minimum element, by the way, that minimum pivot element, what we really do is this particular little piece of code will give us this r pointer. We return num r. Rather than this num r, we should just return r, which basically return this pivot index. Okay, so we have our left pointer, we have our left pointer, and we have our right pointer. We find out the mid. You know how to find out the mid. Mid in this case 5 plus 5 minus 0 by 2, which basically takes us to 2. Okay, so this is our mid. Now we check if our mid num is greater than r. Is it? No, it's not. So what do? We basically, and the target here is 2. Remember, the target is 2. And you can already see with this logic, what you can see is when we are moving our right pointer from basically end to mid minus, or actually just mid, not mid minus, just mid. Okay, so you already see that we have skipped this part, haven't we? We already skipped this part. And even if we keep going, now we'll find the mid as basically this one. This one will be my next mid, and we'll check that this condition will again not follow, and then we'll push our mid over here until this particular condition becomes false, and basically we return mid as like 0 or something, 0 or 1. But you remember that we actually missed this part where the actual value 2 is located. We missed that. So what do? What change do we make? What is it that causing this problem actually? So if you realize, the problem is this duplicate element, because this thing worked in the previous question. It's the duplicate element. So how about we skip these duplicate elements, either in the left or in right? And that's what we will change, and that will make our problem absolutely run fine and give us basically this target elements if it is in our this rotated sorted array or it is not present. So so what do? We will introduce this block of code over here, little code over here, and before we basically start calculating mid, how about keep moving right back and keep moving left in the front until you keep seeing these duplicate elements. So if my right is basically equals to r minus 1, then move your r basically r minus 1, and if your left is equals to your l plus 1, your l index is value is equal to its next value, then keep moving this to the next. Okay, that's exactly what we will introduce over here. Just two lines of code, and that will be basically just simply exact logic that we talked about here to eradicate, to basically get rid of these duplicate value. We're not getting rid of one, we're only getting rid of duplicate copies of one. Okay, so what do we add here? What do we add over here? So let me just like get this little clean and tell you guys like what I mean, what we do. Okay, so this is what we are going to do. At this place we will still have everything like that, and at just this place we will introduce two lines of code, not just two lines, maybe like 4 lines. So while L is lesser than R and L is equals to L plus 1, and by this I just mean the values. Okay, I mean the values here. If this is true, then keep moving your L plus plus. I'm writing the pseudocode, although this is not how you write in Python, that wouldn't work. And just same thing we also do for our right pointer. So while R is greater than L, same condition actually, and R is equals to R minus 1, values again. Okay, values, and R minus, okay, these two. And if we add these two lines of code into our basically sorted array, by the way I should have made this second. Okay, we're solving second. So if we basically add these two lines of code into our basically the search and rotated sorted array first, that code that should run fine on this particular question as well. So let's go back to our code. So, and we will actually go deep in there, like why it's working, why it should work. Okay, let me zoom out, let me zoom out. So basically this was the code for our sorted search and sorted rotated array. So first thing first, I'm just going to copy this helper function, and we know how to write it, so just I guess like don't worry about it, like I'm sure you know at this point like how to write this. So this is like our helper function, which basically it returns -1 in this case, but we're gonna make it return true and false, right? True and false. If we are able to find this target in this particular range from left to right, then we should return true, otherwise we return false. In previous case we were returning +1 and negative, not +1, I mean index or -1. Then we're gonna copy the rest of the code, and I'll paste it over here and introduce those changes. Okay, so again same thing, left and right pointers. Left is lesser than R, so we keep calculating mid, and if mid is greater than your right pointer, that means if mid is greater than your right pointer, that means what really must have happened, we have some elements which are sorted. So in this case we'll move our left pointer to basically move up. So we have understood this in detail, because if mid is greater, that means mid is not the element that we are looking for. What does this mean is, this mid has been pushed from the back, it has been pushed from the back, and there are certain elements before this mid that were completely pushed from the back, because everything before this must be sorted, right? And the same thing happens when basically I even forgot what I was doing. Yes, so you keep moving basically this left pointer to front, because somewhere among these next will be a point which is like basically minimum, right? So that's what we keep getting towards that point. Except one little thing, this will not work when basically our elements are repeated in that, and we have seen that in that example. Okay, it can skip through the right window. Okay, so what we will do is, before we even start calculating mid, and by the way, when this R is that pivot, when this R is the pivot element, we have understood this in previous problems. Okay, so I'm gonna write basically those 2 lines of code that I was talking about. So while left is lesser than right pointer, then we will basically also, let's check it in the same line, and nums L is equals to nums L plus 1, right? L plus 1, and it will not go out of bound because of this particular case, because R is a valid index that we are choosing. If you see over here, so it will always remain valid. So L plus equals to 1, and same thing we do for the right element. Okay, so not element, right, right index. Okay, so same thing, condition remains same. If right is equals to right minus 1, then we will decrement right to avoid these duplicates from left and right both. And then once we are done, there might be multiple duplicates, and we keep doing that until we reach basically this window that doesn't have these repeated elements, and then it becomes a window where like there are no repeated elements. Even if it doesn't become a window that doesn't have repeated elements, we will be able to reach again when we do this particular bullshit basically not bullshit, but like these are key steps. We will be able to turn that input to basically half, and start searching on this new input where we are sure that we will find our element. So this thing goes on, and then once we are done removing these duplicate elements, then we enter the same logic. All right, so this R that's returned to us now, it's the pivot element, and everything before R is sorted, everything after R is sorted. So what I'll do is I'll try to find my answer between these, in one of these, right? This will return me either true or false, or this will return me either true or false, and what I want to return is either of these. Okay, so if either answer 1 is true, or answer 2 is true, so I'm just going to write or. Okay, and that's it. I'm already zoomed out, so I don't have to, and I guess at this point we can just run this on our examples. Okay, little problem is this is not indented, and I did not intended this was an indented, and I did it intended. Oh my god, I'm so lame. My jokes are lame, actually. I'm not lame. Okay, this runs on the example, so I'm gonna submit it. This little part did the trick. Okay, oh my god, it's 100% also. So okay, so this little part did the trick to basically avoid those duplicate values, bringing them to a point where like these two values that they're not same. I mean, like, start your logic once you know that you don't have like a duplicate value for your current left and right pointers. Keep seeing these left and right pointers and keep bringing them towards each other, and that's what we are doing, and we do it in a lot of other problems as well. So let's write down the time complexity. Time complexity will be basically, honestly, worst case it could be big of n, but honestly best case or average case should be even in average case also it could be big of n, but best case big of log n, because at the end when you basically find that pivot element, you're basically running the binary search. Okay, and space complexity would be big of 1, that is constant. Okay, so this will be the answer. You can have a look over here, and this is exactly same, just like this particular this code, not this code, I mean this code, and except just little thing here we added that duplicate thing. And you know what, even I think this code should be able to run here as well. This code should be able to run there as well, because at the end of the day these cases still apply here. These cases still apply here in this problem. Okay, so there might be a case where elements don't repeat, so this code should be able to run here. You can try yourself, and see you guys later. Now I'm gonna go back to AlgoYogi and mark this solved, and see you guys in the next video. Bye bye.